For topic 4, we're going to look at solving multi-step equations. So far, we have solved just one-step equations by applying the addition property of equality and the multiplication property of equality. When you have multi-step equations, you're going to have a much bigger looking equation, meaning we just have a lot more terms. And so what we're going to have to do is we're going to have to simplify that equation down to where we can apply those two properties. So we need to simplify the equations so that we have at most one variable term and one constant on each side. Once you get to this point where you have at most a variable term and a constant on either side of the equation, then you know it's time to apply the addition property of equality and the multiplication property of equality. You never want to start moving things around until you get your equation as simplified as possible. And the best way I can make this make sense is imagine moving, like you're moving your home, like you're moving from one apartment to the next, one house to the next, whatever. You don't pack one box and move it to the new house at a time. Instead, you pack all your boxes and you put them in one moving truck at a time. So you want to make the fewest trips between the two houses as possible. So we don't apply the properties until we get to the point where we have at most one variable term and one constant on each side of the equation. Okay? Now, how do we know how to do this? Well, there's a set of steps that we're going to follow. I kind of wish I had numbered these instead of just using bullets, like the bulleted list. So the first step is to apply the distributive property to eliminate parentheses. If you have an equation that contains parentheses, get rid of them, okay? Step 2, once you get rid of parentheses, simplify each side of the equation, okay? This means combine like terms on the left, combine like terms on the right separately, okay? So we do this by combining like terms. And then at this point, at the end of step 2, you'll have at most one variable term and one constant term on the left, and at most one variable term and one constant term on the right. And this is when you apply the properties, okay? Step 3, you apply the addition property of equality, and you sometimes have to do this property twice. The first time you do it, you want to get all of the variables on one side of the equation, typically the left. And then you want to get all of the constants on the other side of the equation. And what that does is it gives you an equation where one side is a variable term all by itself, and the other side is a constant term all by itself. And at that point, you apply the multiplication property of equality. Okay, so that's the 4-step process we're going to start with. And then in a bit, we'll look at clearing fractions and maybe decimals. And we have like an extra step before step 1. So we have like a pre-step 1. Okay. So let's go ahead and practice. The directions for example 4 say solve each equation. Now notice I don't tell you to check your work here, just know that you always can. So like back here in example 3, after we solved our equations, we could check to make sure the solution was good. We're not going to do that for every single problem always, but just know that you could if you wanted to. Okay, but for the sake of time, we're going to skip that for now. Okay. So for our first example, we have 2 times, in parentheses, 3x minus 2 times, in parentheses, 5 minus 2x. All of that equals 4. Okay? So the first thing I want to do is get rid of parentheses, and I have to distribute 2 different times. So for the first set of parentheses, I'm distributing a positive 2. So this means I want to take this 2 and multiply it by 3x and then by negative 2. Okay, so 2 times 3x, I just multiply the 2 and the 3, which gives me 6, and then I keep the x. And then 2 times minus 2 is really 2 times negative 2, which would be negative 4. Okay, and then for the second set of parentheses, I have a minus 2, so I'm going to distribute negative 2 through the second set of parentheses. So negative 2 times 5, negative 2 times negative 2x. Okay, so negative 2 times positive 5 is going to be negative 10. And then negative 2 times negative 2x, I want to multiply the negative 2 times negative 2, which gives me 4. And then I keep the x, and all of that is equal to 4. Okay, this is not a time to try to skip steps and do stuff in your head. Number one, I can't grade what's in your head. Number two, just take the time to write out your steps. Don't try to rush the process. When you rush the process, you miss little things and then you end up getting points taken off. Okay. Now at this point, we want to combine like terms. Okay. So notice I have X terms, and then I also have, let's change colors. I also have just constant terms. Okay, so we want to simplify the left so that we have one variable term and one constant term. So let's look at the variable terms first. So I have 6x plus 4x. 6 plus 4 is 10, so that's going to give me 10x. Okay, and then for the constant terms, I have negative 4 minus 10. Negative 4 minus 10 is negative 14. So I get 10x minus 14 equals 4. And at this point, it's as simple as it can get until we start applying the properties. So we have a variable term and a constant on the left, and then we have just a constant on the right. Okay, now our goal for step 3 is to apply the addition property of equality. And what we do there, the whole purpose behind the addition property of equality, is to get the variable terms all together and in a single place, and then get all of the constant terms all together on the other side of the equation. Okay, so we only have one variable term, so I'm just going to isolate it. I want to isolate the variable term, so my issue is minus 14. Okay, how in math would we undo subtraction? Well, we already know that to undo subtraction, we would use addition. So let's add 14 to both sides. By adding 14 to both sides, we'll be able to isolate the 10x because negative 14 plus 14 is 0. So we can say the 14's cancel because 10x minus 0 is just 10x. And then 4 plus 14 is 18. So now I'm in a situation where I could apply the multiplication property of equality. I have a single variable term equaling a single constant term. Let's finally get the variable by itself. So we need to undo the multiplication of 10 and x. Well, to undo multiplication, we divide. So we want to divide both sides of the equation by the coefficient of x. So divide both sides by 10. On the left, 10 divided by 10 is 1. So 1 times x is x. So we could say the 10's cancel. And then 18 divided by 10, this is something that bugs math students. We don't generally write this as a decimal or a mixed number, okay? When you're solving these generic equations, the best format for your answer is a reduced fraction, okay? So we're not going to write this as a decimal. We are not going to write this as a mixed number. We're just going to reduce our fraction, okay? Now, I happen to know that 18 and 10 are both even, so I'm going to start by dividing them both by 2. And when I do that, 18 divided by 2 is 9, 10 divided by 2 is 5, and that is as simple as it's going to get. Okay, so we would say our final answer here would be 9/5. And if you don't believe it, take some time, pause the video, go back in and check your answer. Okay, and you should get a true statement. Now, if we were to make this fancy, remember fancy, whoops, I forgot my C. There we go. Fancy. There's a little lag. There we go. So if we're going to write this fancy, remember that set notation. So that's where we use the curly braces. So set notation, we don't write the x, we just say whatever the value for x is. So we write that inside curly braces, and it translates to the solution set contains the value 9/5. Okay? So that is solving a multi-step equation. Let's try it again. So part B, we have 4, and then in parentheses, we have times 3x plus 4. Then we have minus 20 equals 3 plus 5x. So very first step, if we go back and look at our 4 steps, the very first thing we want to do is distribute to get rid of parentheses. Okay? So we need to distribute a 4. So I have 4 times 3x and then 4 times 4. Well, 4 times 3x, I just want to multiply the 4 and the 3. That gives me 12. And then I keep the x. And then 4 times 4 is positive 16. And then just rewrite the rest of the equation. So I have minus 20 equals 3 plus 5x. Okay. Now on the left, we want to simplify it as much as we can. We want to simplify it to where we have at most one variable term and at most one constant term. Well, luckily, we only have one variable term on the left. So we just need to simplify our constants. So we have 16 minus 20. So 16 minus 20 would just be -4. So this is going to become 12x minus 4 equals 3 plus 5x. So we're at a point now where the left-hand side has a single variable term and a single constant term. The right-hand side has a single variable term and a single constant term. This is when you apply your properties. So what we want to do is notice we have x's on two sides of this equation. We want all of our x's in a single term on one side of the equation. And notice we also have constants on two sides of the equation. We want constants together in a single term on the other side of the equation from the variables. So let's start with variables. We always do variables first. Typically speaking, you move your variables to the left. That's kind of the old school mathematician in me. I always move my variables to the left because we want it to finally say variable equals some number. So that means I want to move my 5x. So I have positive 5x. That means like plus 5x. How would I undo plus 5x from the right-hand side of the equation? Well, we already know to undo addition, we use subtraction. So let's subtract 5x from the right and from the left. And that'll basically move it from the right to the left because what is 5x minus 5x? Well, 5x minus 5x is 0, and 3 plus 0 is 3. So we could say the 5x's cancel from the right. Okay, just know why they cancel. And then on the left, we have 12x minus 5x. That would just be 7x. And then don't forget you got this minus 4 to drop down. So we have 7x minus 4 equals 3, which is great. We got all of our variables in a single term. Now we want to get all of our constants in a single term on the other side from the on the other side of the equation from the variable term. So that means I want to deal with this minus 4. Okay, so we have this 7x term, but we're subtracting 4. We need to undo that. The way we undo subtraction is addition. So I'm going to add 4 to both sides. Well, -4 plus 4 is 0. 7x plus 0 is just 7x, so we can say the 4's cancel. And then on the right, 3 plus 4 is 7. So when you get to the point where you have a single variable term equaling a single constant term, that's when you apply the multiplication property of equality. We finally want to get the variable by itself. We need to undo the multiplication of 7 and x. We undo multiplication with division. So we want to divide both sides of the equation by 7. Scroll down a little bit. And on the left, 7 divided by 7 is just 1. So that just sort of becomes a 1 when we divide. 1 times x is x. So that's when we say the 7's cancel. Just know they didn't cancel. They didn't just poof disappear. 7 divided by itself is 1. 1 times x is x. And then 7 divided by 7, again, is 1. So this would be our final answer. And again, we're going to write it fancy. Remember, when you do set notation, you don't put the x inside the curly braces. You just put the value for x. So this says the solution for x, or the solution for this equation, contains the value 1. Okay? And that is solving multi-step equations. So as you're working through homework or whatever, maybe write these steps on a Post-it note or have your guided notes in front of you as you solve. Don't stray from this set of steps. I have students all the time say, can we, skip this step? Can we skip that step? I promise you these 4 steps, this is the quickest, most efficient way to solve a problem. So if you're straying from this set of steps, you're doing too much. Okay? So there you have it. That is solving multi-step equations. I don't want to lie to you. I think we're going to clear fractions, then decimals, then we're going to solve a proportion, and then eventually, we're going to classify equations. This is a long set of notes, so bear with me. All right, so next up, we will clear fractions from equations.